Hello, we're on day 2 of lesson 6.5, still talking about operations with functions. So today we are going to use algebraic expressions to put into functions. Here I still have this composition of functions thing. You have f of g of x, f of g of x, or f composed of g of x. Let's take a look and start doing this. So if you look at 4a, it says write f of g of x and state the domain. So there's no specific number here to put in. So that means we're going to put in the entire function. So let's look at this. It looks like g is going to go inside of f. So that means I'm going to take g and put inside of the x of f. So that's going to look like, we'll write f of g of x. When I write it out, I'm going to write this, and I'm just going to leave a big space for the x right now. So that's my f, my outside function, f of x plus 2. But instead of x, I'm going to put in the 2 over x minus 1. And then I'm going to simplify this. So this is 5 times this fraction, which is the same thing as 5 over 1. So I'm going to have 10 over x minus 1 plus 2. And the only other thing I have to do, because I don't really need to simplify that any further, the last thing I need to do is state the domain. So the domain is anything that x cannot be, which is just 1, okay? Because the denominator would be 0. So this is my answer. We'll do the same thing, but the other way around. It says to write g of f of x. So that means I'm going to take the f function and put it inside of the g function. So I will write g of f of x, and I'm going to put the f function inside the g function when I find, or for x. So I'm going to kind of write the g function, and I'm just going to leave a space for my x. So this is 2 over x minus 1, but instead of x, I'm going to put in the f function, which is 5x plus 2. And then I just need to simplify that a little bit, which doesn't take much. 5x plus 2 minus 1 is just 5x plus 1. And then I just need to state my domain, which is just x cannot equal a negative 1/5. And I got that by setting the denominator equal to 0 and solving. Okay. So g of f of x is this with my domain. Let's do another problem. So f of g of x, and this time my f looks like this and my g looks like this. So I'm going to put the g inside of the f. So I will write this out. So I'll write my f, kind of my host function here, leaving space, my x, 3x minus 4, but instead of x, I'm going to put in my g function, square root of x plus 2. Need to simplify that a little bit, so I'll just distribute that 3 square roots of x plus 6 minus 4, which is 3 square roots of x plus 2. And I still need to write my domain, which is the only thing that can't be underneath a radical is a negative number. So x is going to be anything greater than or equal to 0. Yeah, that's nice. Okay. one last one here. G of f of x means that I'm going to take the f function and put it inside of the g function. So I'm going to take this and put it in for the x right there. So I will write this, and I will put my f in to replace that x. So I have 3x plus 4 right here. And there's really nothing I can do to simplify that one because this is all under the radical, so that has to kind of stay the same. I wouldn't necessarily need the parentheses, but no biggie. And then I just need to write my domain. Well, under the radical has to be positive, so 3x plus 4 has to be greater than 0, and I'm just going to jot that down to kind of figure it out. Or equal to, I guess. And so I'm going to solve for it. So I'll subtract my 4 and divide by my 3. So x has to be greater than or equal to negative 4 over 3, and that would be my domain for this. All right, that's it for this lesson. It just takes practice, and that's hopefully not too terribly confusing. Let me know as you have problems. Thank you.